All right, so today we're going to be looking at another infinite series, the infinite series that you see on your screen in particular. And again, we're going to be asking whether or not this infinite series converges or diverges. So as you add up all the terms in this sequence, does the sum just keep getting bigger and bigger and go off towards infinity, or does it converge towards a certain number? And again, if this is a convergent geometric, we're going to try and find the sum of the infinite series. So the first test that we're going to use is the divergence test, which states that if the limit as n goes to infinity of the sequence does not equal 0, the series must diverge. And if the limit of as n goes to infinity of the sequence does equal 0, the test is inconclusive. So we'd have to use another test to figure out whether or not it converges or diverges. So to find the limit of this series, I think it's going to be really helpful if we write out a bunch of terms. So the first term is going to be a sub 1, which is equal to 3 plus negative 1 to the power of 1. Well, that's just 3 plus negative 1, which is 2. The next term is going to be 3 plus negative 1 squared. Well, that's just 3 plus 1, which is 4. The next term is going to be 3 plus negative 1 to the power of 3. Well, that's just 3 plus negative 1, which is 2. The next term is going to be 3 plus negative 1 to the 4. Well, that's just 3 plus 1, which is 4. And as you can see, there's a pattern forming here, and that for every odd term, this is always going to be 3 plus negative 1 to an odd power. Since negative 1 to an odd power is always negative 1, this is always going to be 3 plus negative 1, which is equal to 2. And the same thing happens for every even term. For every even term, this is just going to be 3 plus negative 1 to an even power. And since negative 1 to an even power is always positive 1, this is always 3 plus positive 1, which is 4. So as you can see, for every odd term, this sequence is always going to be equal to 2. And for every even term, it's always going to be equal to 4. So that way we can write the limit out as two separate limits. That if n is odd, the limit of the sequence is always going to be equal to 2, and if n is even, then the limit is always going to be equal to 4. So as you can see, as the sequence continues, it's just going to keep alternating between 2 and 4, 2 and 4, 2 and 4, and it's never going to come out to one number, meaning that the limit of this sequence does not exist. And since the limit does not exist, the limit does not equal 0. And since the limit does not equal 0, by the divergence test, this infinite series diverges. And if you think about it, this does make sense because for this infinite series, you're just adding 2 plus 4 plus 2 plus 4 plus 2 plus 4 forever. And that's always going to, the sum's always going to keep getting greater. It's never going to converge to a certain number. And yeah, that's pretty much it. So for the last slide, a little bit about myself. I run cross country, indoor track, and outdoor track. So I included some cool pictures of me running here. Since 7th grade, I've ski raced for the Stratton Mountain team in Vermont. And this year I actually, for the first time, ski raced for the Newtown High School ski racing team. And I bet you didn't even know we had a ski racing team. And that's probably because this is the first year it existed. Me and my siblings were able to convince Memily to let us form a Newtown High School and Pomperaug High School co-op team, which was pretty cool. And we actually won the state championship this year, which was pretty cool as well. So here's some cool pictures of me skiing. And I also do Boy Scouts year round. So here's a cool picture of me doing Boy Scouts. And yeah, that's it.